Imagine standing barefoot on a beach. Your toes sink into the sun-warmed sand, enveloping your feet in heat. As you dig your toes deeper, the surface heat gives way to a surprising coolness. Untouched by the sun, the sand beneath is a refreshing contrast. Have you ever wondered what's beneath all that sand? Is it just more sand all the way down, or is there something else? Something hidden beneath those countless grains? In 2012, scientists at the University of Hawaii estimated that there are 7 quintillion 500 quadrillion grains of sand on all the Earth's beaches. That's 7.5 times 10 to the power of 18 grains of sand. But what exactly is sand? In the simplest terms, sand is tiny pieces of rocks and minerals. But how do these rocks and minerals become sand? First of all, not all sand is created equal. The sand you find at the beach is different from the sand in the desert, and that's because of how it's formed. For example, beach sand is often made up of quartz and shell fragments, while desert sand might contain more feldspar, a large group of rock-forming silicate minerals that make up over 50% of Earth's crust. Let's get back to our beach. The sun is warming your skin, the sound of waves crashing nearby. You reach down and let the sand trickle through your fingers. It's soft, almost silky. That's beach sand for you, a product of a long, slow dance between the sea and the land. Beach sand is mostly made from rocks and shells that have been ground down by the constant motion of the waves. It's a process that takes hundreds of thousands of years. The waves, with their relentless ebb and flow, act like a giant rock tumbler, constantly churning, grinding, polishing. Over time, these rocks and shells break down into tiny pieces and become the soft, squishy sand we love to walk on. Each grain is a testament to the power of the sea, a tiny piece of history. But what about desert sand? Deserts are dry and windy, and there's not a lot of water to help break down rocks. Instead, the wind and extreme temperature fluctuations do most of the work. In desert environments, the temperature can vary dramatically between day and night. During the day, the sun can heat the desert surface to extremely high temperatures. Then as night falls, the temperature can plummet rapidly without the insulating effect of humidity or cloud cover. These rapid and extreme temperature changes cause the rocks to expand and contract. Over time, this constant expansion and contraction can cause the rocks to crack and fracture, breaking them down into smaller and smaller pieces. The wind then takes over, whipping across the barren landscape, picking up these tiny pieces of rock and carrying them aloft. Over time, these particles are deposited in new locations, forming the towering dunes we associate with deserts. But this process isn't as simple as it sounds. The wind doesn't just pick up pieces of rock and move them around. It's not a random process, no, it's a delicate balance, a finely tuned system governed by the laws of physics. The wind has to be strong enough to lift the grains off the ground, but not so strong that it blows them away completely. Let's go back to our beach again. As you sit there enjoying the feel of the sand between your toes, you might have asked yourself, what's actually underneath it? How deep does it go? And what's below it all? Turns out you're actually sitting atop layers upon layers of material, each with its own story to tell. If you've ever dug a hole at the beach, you'll have noticed that after a certain point, the sand starts to get wet. This isn't just because you're close to the sea. You're actually encountering something called the water table. The water table is the upper surface of the groundwater, the point at which the soil or rock is completely saturated with water. It's like an underground river flowing silently beneath the surface. The level of the water table can vary greatly depending on rainfall, the time of year, and the type of soil or rock in the area. But let's keep digging. As you go deeper, the sand becomes denser, more compact. It's not as easy to dig through, but with some effort you can keep going, and then suddenly your shovel hits something hard. You have reached what's called the bedrock. Bedrock is the solid rock that lies beneath the sand and soil. It's like the foundation of a house, providing a stable base for the layers of sand and soil above it. The type of bedrock can vary depending on the location. It could be limestone, granite, basalt, or any number of other types of rock. This bedrock is ancient, often millions or even billions of years old. It's a silent witness to the Earth's long history, bearing the scars of glaciers, earthquakes, and the relentless passage of time. But what about deserts? What's under all that sand? And how deep does the sand go? You might be picturing endless depths of shifting sand, but the reality is actually quite different. In fact, most deserts aren't covered sand at all, they're mostly bare rock or gravel. This might seem surprising given the images of towering sand dunes that often come to mind when we think of deserts. But these sandy areas, known as ergs, only make up a small portion of desert landscapes. And take the Sahara, for example. It's the largest hot desert in the world, roughly the size of the United States, but only about 20% of the Sahara is covered in sand. The rest is made up of areas like Hamada, which are flat rocky surfaces, and Red, which are gravel-covered plains, similar to what you might find on Mars. The sand in the Sahara is found in dunes that can reach incredible heights. Some dunes in the Sahara can tower over 180 metres, 590 feet high. That's taller than the Sydney Opera House. But even these massive dunes are not purely made of sand. Beneath a certain depth, you'd find a layer of solid rock or compacted soil known as hardpan. The depth of the sand in deserts can vary greatly. In some places, the sand might only be a few meters deep. In others, it could extend down for several tens of meters. But eventually, if you dug down far enough, you'd hit bedrock again, just like at the beach. This bedrock can tell us a lot about the history of the desert. In the Sahara, for example, the bedrock includes layers of sedimentary rock that were laid down when the area was covered by a shallow sea millions of years ago. These ancient rocks provide clues to a time when the Sahara was a very different place. Now here's where things get really interesting. The Sahara hasn't always been a desert. In fact, it's gone through multiple green phases throughout history, where it was covered in vegetation and home to a variety of wildlife. In 2010, scientists made a fascinating discovery that provided a glimpse into one of these green phases. Beneath the sands of the Sahara, they found evidence of a prehistoric mega lake. This wasn't just a small body of water. No, this was a lake of epic proportions, larger than some of the Great Lakes in North America. This mega lake, which scientists believe formed around 250,000 years ago, was thought to have been created when the Nile River changed its course and spilled into the Qattara Depression, a low-lying area in the northern part of the Sahara. The resulting lake, known as Lake Megachad, I'm not kidding, covered an area of about 400,000 square kilometres. That's larger than the entire state of California. This discovery paints a picture of a Sahara that was a lush green landscape, teeming with life. Imagine herds of elephants and giraffes wandering along the shores of this vast lake, while crocodiles and hippos lounged in the water. It's a far cry from the barren desert we know today. But the Sahara's transformation from green to desert wasn't a one-time event. In fact, it's thought to have happened multiple times over the past several million years, driven by shifts in the Earth's tilt, axis and orbit around the Sun. These shifts, known as Milankovitch cycles, affect the amount of sunlight reaching different parts of the Earth, leading to changes in climate that dried out and buried the lake. But the Sahara isn't the only place where surprising things have been found beneath the sand. In some places, entire forests have been discovered under moving sand dunes. That's because sand dunes aren't stationary, they move with the wind, and over time they can cover up anything in their path, including trees. But when the wind changes direction, the dunes can move again, revealing what was once hidden. And then there are sinkholes. These holes form when the ground collapses, and they can often be found in sandy areas. Sinkholes form when water dissolves the rock beneath the sand, creating a cavity. When the sand above this cavity becomes too heavy, it can collapse, forming a sinkhole. These sinkholes can be dangerous, but they also give us another way to see what's beneath the sand. So the next time you're at the beach or watching a documentary about the desert, remember that there's more to sand than meets the eye. Beneath the grains of sand, whether on a beach or in a desert, lies a world shaped by the forces of nature. from the water table and bedrock at the beach to the hard pan and ancient bedrock in the desert. These layers, often hidden from our sight, tell a story of Earth's dynamic history, revealing that our planet's landscapes are not static, but constantly changing and evolving over time. So the truth is that beneath all those tiny grains, there's a whole world waiting to be discovered. A world of rock, water, and sometimes even ancient lakes and hidden forests. But beneath one part of Africa, something far greater is happening. The continent itself is slowly splitting apart. Deep below Ethiopia's Afar region, the Earth's crust is stretching, magma is rising, and scientists believe a new ocean is beginning to form. To see how Africa is breaking apart and how an ocean can be born in the middle of a desert, tap the video on screen.